All right, you guys, so we're only working off of those specific questions that are going to be on the test that we circled in class, starting with question number 4. So determine the following. Well, when it's in general form, I can go ahead and see the y-intercept. That's right here. And for this, also, you could just graph this and find most of this information. To find the x-intercept, I need to factor this. So it's going to be f of x equals x plus 6 times x plus 1. So I was looking for two numbers that added up, 5, added up to be 5 and multiplied together to be 6. But do not forget, these are not your, I do not want you to put for the x-intercepts positive 5 and positive 1. You have to find the zeros. You have to figure out what value makes that 0 and what value makes the 0. So the x-intercepts are going to be negative 5 and negative 1. The vertex means that we now need to put it in vertex form to find that, which will actually then be part E. In order to put it in vertex form, we're going to complete the square, but we're just going to do it on one side, so it's a little bit different. So f of x equals, parenthesis, x squared plus 6x. Then we're going to leave a space. Then we're going to put plus 5. Now we're going to complete the square. So half of 6 is 3. 3 squared is 9. So we're just going to add 9. And normally we would add 9 to both sides, but since we're just staying on one side, I also have to, if I'm going to add it, I also have to subtract it. And that's where our h comes from, is positive 5 minus 9. Or our k, I'm sorry. So then let's change this. The whole reason we did this was to find a perfect square, which in this case is x plus 3 squared. And then on the outside we have minus 4, positive 5 minus 9. It's f of x. So that's the vertex form. You can write that down here for E, and then the vertex is negative 3, comma, negative 4. Remember, the vertex has to be the opposite of this value in here. If you just have the one, if I'm just adding it in there. The axis of symmetry is just going to be negative 3 because that's the vertex. The domain for a quadratic or any polynomial is all real numbers. The range, let's graph it first to find the range. If my vertex is negative 3, negative 4, negative 3, 1, 2, 3, 4, and my x-intercepts are negative 5 and negative 1, and my y-intercept is positive 5, it's going to look, it's a positive function, something like this, right? And so my range, the smallest number my x value can ever be is negative 4, and it can be negative 4. So my range is going to be negative 4 to positive infinity. The function is increasing from negative 3 to positive infinity, and it's decreasing from negative infinity to negative 3 also. Okay, and I'm using the rounded parentheses here because at negative 3, it is no longer decreasing. Like that's the end of it. All right, so we also have question 5. Oh, a rectangular corral split into 2 pins. And I feel like we did this, I feel like I did this with everybody on your web work, but let's go ahead and go through this. The same size so that we have 3 widths and 2 lengths, length and length. And we know the perimeter is 300 feet long, or our greatest perimeter can be, or the most amount of fence we have is 300 feet long. But don't forget, we also have to count this W here. So if I add up, my 300 feet needs to be equal to all my widths, all of my widths, all 3 of my widths, plus all 2 of my lengths. And my area is going to be equal to my width times my length, right? The area is going to be equal to length times width. But let's solve, since when we graph this, we have 3 variables right now, so I need to put W in terms of L. That's the way I'm going to do it, because I can see 300 divisible by 3 works. I guess you could do it either way. Just be careful when you're done. So I'm going to put this equation, I'm going to solve for W in terms of L. So what does that mean? So I'm going to erase this first part. And I'm going to solve this equation up here for W. Okay, so first I'm going to subtract 2 L's from both sides. So then I have 3W is equal to 300 minus 2L. Then I'm going to divide everything by 3. So we get W is equal to 100 minus 2/3 L. Now I just can say, instead of length times width, I can say for my area, I'm going to have length, which is just L, times my width, which is actually 100 minus 2/3 L. And now that's a quadratic. All right, so when you graph this, it should look something like this. And so I'm just going to say graph it on your calculator. And if you find the maximum point, that maximum point is going to give you the x value is actually going to be the length in this particular case. And here's where everybody screws up. The y value is going to be the area, the maximum area. Not everybody thinks the y value is the w in this case. No, you're going to get length and area. Then you're going to have to use this length, substitute it back in somewhere, wherever you want, and then solve for the width. All right? So, but just put it in your calculator and you can figure that out. Same with this next one. Let's see. How many seconds does it take to reach its maximum height? Or can 16 go into 80? Let's check. Let's see. Can 16 go into 80 evenly? If it can, then we can just complete the square. Divided by 16. Yeah, 5. All right, so let's do that. Or you can just put it in the calculator, whichever you prefer. But since I don't have a calculator handy, I'm just going to do this. So if I factor out this negative 16, I just have t squared plus, oops, I factored out a negative, so t squared, I'm sorry, minus 4t plus, leave a space, parenthesis, plus 80 on the outside. I wonder if I can write, well, oh, it disappears for some reason. Okay, so half of negative 4 is negative 2, squared is positive 4, so I'm going to add 4 in here. But, and here's the tricky part, you can multiply that. We have to multiply that by negative 16. So I'm technically subtracting 64. So on the outside out here, I have to add 64. So then I have negative 16 times t minus 2 squared plus, oh, what is that, 144? You guys are, I'm going to make you guys double check me. If that's not 144, then I'm doing all of this from here on out is going to be the incorrect answer. So my vertex is reached after 2 seconds. Oh, so that's the answer. It takes 2 seconds to reach its maximum height. The maximum height is going to be 144. Boom. Boom goes the dynamite. What's next? Number 7. How much time do I have on this video? All right, write an equation for the graphed function in general or standard form. So it doesn't really matter which. I'm only going to do this one time. So let's do the negative one. Let's do vertex form. For some reason, that's the easiest for me when I'm writing an equation. My vertex is here, -1, 8. So I have f of x, or let's just call it y because that'll help you out with what else we're going to do. We have y is equal to, and I have to put an a here because we don't know if it's been stretched, right? Maybe, maybe not. And then my vertex is going to be x plus 1, because it's going to be the opposite there, squared, plus 8. Then I'm going to take any one of the other points besides the vertex, and I'm going to substitute in for x and y so I can solve for a. So let's do just the y-intercept so that I get, if my x is 0, my y is 6. Working with 0 is always easiest. So then I get 6 is equal to 0 plus 1 is 1. 1 squared is still 1. So I get just a plus 8. Then subtract 8 from both sides, and I get a is equal to negative 2. So the entire function should be f of x is equal to negative 2 parenthesis x plus 1 squared plus 8. There you go. What's next? Ooh, now we get to skip down to question number 13. No, I guess it wasn't as far as I thought it was. What is the least possible degree of the graphs below? So if you have 2 turning points, the least possible degree is 3. You have to have at least x cubed, right? And here we have 3 turning points. So the least amount you can have is x to the 4th power. And that makes sense because this is even, right? And here we have 1, 2, 3, 4. So this must be x to the 5th. Determine the x-intercepts of end behavior of this. Oh, so this is a positive cubic function, right? So that means eventually, if we're only looking at the end behavior, eventually it's going to go towards positive infinity. It's going to keep going up, right? So as x goes towards positive infinity, so does the function goes up towards positive infinity. And my zeros, so what makes that 3 times what squared is going to give you 0. So one of my zeros is 0. And when you guys are taking the test, make sure you label this for me. Otherwise, I might think it's a point or something. So these are going to be the zeros or the x-intercepts. And then in here, this one's going to be negative 2. So 0, negative 2. Determine the x-intercepts, and oh, I did 14. I didn't have to do that. Well, 15 is going to be the same as 14, so I'm going to skip that one. Number 19, but if you want to get extra practice, then you can do 15. Number 19, find the zeros of the polynomial and state the multiplicity of each. Oh, okay, so here this has zeros negative 6, which has a multiplicity of 2 because it's being squared, and then it has another 0 at positive 6 with the multiplicity of 3. Here we have a 0, 0 with the multiplicity of 2, a positive 9 with the multiplicity of 1, and a negative 4 with the multiplicity of 3. All right, I'm going to end this video.